Have you ever wondered how all those different pieces of network security you've been studying, firewalls, VPNs, intrusion detection, how they all actually fit together in a real-world company? Well, that's exactly what we're going to do here. We're going to build a complete security architecture from the ground up, giving you that big picture view you absolutely need for your final exams.
So, let's start with the stakes. $4.35 million. According to recent research, that is the global average cost of a single data breach. Just let that sink in. A number like that is precisely why having a solid, well-thought-out security architecture isn't just a good idea, it's completely non-negotiable.
And this slide right here shows us exactly why those stakes are so incredibly high. Just look at this evolution. We've gone from dealing with pretty simple viruses back in the day to facing full-blown cyber warfare and complex ransomware today. The threats aren't just getting more common, they are so much smarter, way more targeted, and just plain more dangerous. This is the battlefield we're on, and that means our defenses have to be just as sophisticated.
All right, let's dive in. Here's our game plan for today. First, we'll cover the why, the core principles we're protecting. Then, we're going to build our fortress, layer by layer, starting with the perimeter. After that, we'll post our digital guards inside and then lay down the law for what's allowed. And finally, we'll see how it all clicks together to create one unified, tough-as-nails defense. Let's do this.
Okay, first things first. Before we can even think about building walls and setting up guards, we have to understand what it is we're fundamentally trying to protect. This is the why behind every single security decision we're about to make.
At the absolute heart of everything is the CIA Triad. A great way to think about it is like a three-legged stool. So you've got confidentiality, which is all about keeping secrets, making sure only the right people can see the data. Then there's integrity, which is all about trust. Is the data accurate and has it been tampered with? And finally, availability. Can you actually get to your systems and data when you need them? If any one of those legs gets wobbly, the whole thing comes crashing down.
But here's where it gets really interesting, and this is a key insight for your exams. These three principles are often fighting against each other. You can't just crank all the dials up to max. For example, if you make your data super-duper confidential with tons of encryption, you might make it a real headache to access, which hurts your availability. It's a constant tug of war, and the real art of security architecture is finding that perfect balance for what you need.
All right, let's get building. We're moving to our very first layer of defense. It's time to build the outer walls of our digital fortress. This is all about controlling who gets in and who gets out.
And first up, of course, is the firewall. Think of this as your network's bouncer. It stands right at the front door and it checks the ID of every single packet that tries to get in or out. If a packet isn't on the approved guest list, that is, the set of security rules, it is not getting past the velvet rope. Simple as that.
But what about your own people who need to get in from the outside world? That's where VPNs come into play. They create this awesome, secret, encrypted tunnel right through the public internet. It's like having a private subway line that goes directly to your office door. A site-to-site VPN connects, say, two entire offices together, while a client-to-site VPN is for one person, like you working from a coffee shop, to securely connect back into the mothership.
So, what happens if some clever attacker actually manages to slip past our firewall? Are we just out of luck? No way. That's when we unleash our digital guards. These are the systems constantly patrolling inside the network, actively looking for any sign of trouble.
Now pay close attention, because this is a super critical distinction you need to know. We have two main types of these guards, IDS and IPS. An IDS, an intrusion detection system, is like a security camera. It sees something bad happening and it sounds an alarm. An IPS, an intrusion prevention system, is more like a security guard who steps in. It sees something bad happening and it takes action to stop it right then and there. That's the key difference. An IDS detects, but an IPS prevents.
Okay, guarding the perimeter and having internal patrols is great, but that's just the start. Now we need to get serious about enforcing the rules inside our network, controlling who can go where and what they're allowed to do.
This is where we get really specific with our rulebook. Access control lists, or ACLs, are basically the VIP list for our network. We can get super granular and say things like, okay, only allow traffic from this specific IP address to get to our web server on port 80. Or, you know what? Block all traffic from this entire network we know is malicious. It's this level of precise control that lets us really enforce our security policies.
And it goes beyond just traffic. We need to control what actual users can do. The AAA framework handles this perfectly. First is Authentication. That's basically asking, are you really who you say you are? Then comes Authorization, which asks, okay, now that I know who you are, what are you allowed to touch? And finally, Accounting. Keeps track of everything, answering, so what did you do and when did you do?
Now, let's talk about something that can literally bring your entire network to its knees in seconds, a broadcast storm. See, we build redundant links between our switches to make the network more reliable, but those extra paths can accidentally create a deadly loop where data just bounces around forever, faster and faster, eating up all your bandwidth until, poof, the network is dead. Spanning Tree Protocol is the absolute hero that saves us from this nightmare. It's this clever protocol that logically blocks those extra paths, making sure there's only one active route at a time, which prevents loops and keeps our network stable.
And here is a perfect picture of STP in action. Take a look at this diagram with me. STP has calculated the cost for each path to get back to the main switch, the root bridge. Path 1 has a cost of 19, which is way lower than Path 2's cost of 38. So what does STP do? It keeps Path 1 active and puts that more expensive Path 2 into a blocking state. Now, if Path 1 ever fails, STP will instantly activate Path 2, giving us that sweet, sweet redundancy without the catastrophic danger of a loop. Pretty smart, right?
Okay, so we've built our defenses, layer by meticulous layer. We have the perimeter, the guards, the rules. Now for the fun part. Let's see how they all work together as a single, unified team to stop a real-world attack. This is where the magic really happens.
Let's follow an attacker, step by step. First, they try a simple port scan to see if any doors are unlocked. But bam, our firewall's ACL sees it's from an untrusted source and shuts it down, denied. Okay, so the attacker's persistent. They switch tactics and try a known web exploit. But our IPS, our internal guard, sees it coming, matches it to its signature database, and boom, blocks it cold, denied again. And here's the best part. Both of these failed attempts are logged and sent to our central system, our SIM, which connects the dots and shoots out a high-priority alert to the security team saying, hey, we're under a coordinated attack. That is defense in depth in action.
This layered approach is really the core philosophy of all modern network security. It's called defense in depth. It's not about trying to build one single perfect impenetrable wall, because any single wall can eventually be breached. No, it's about building resilience through multiple overlapping layers of defense, so if one fails, another is already there to catch the threat.
So, as you head into your final exams, remember this. Network security isn't about memorizing individual tools. It's about building a cohesive system. It's about understanding how each layer of your defense supports all the others. The real question isn't just what does a firewall do, it's how does my firewall work with my IPS and my AAA server to stop a sophisticated attack? That's the architectural thinking that's going to set you apart. Now go ace those exams.